Hello guys, Untitled here, just coming at you with another video in the Rust programming series, and in this video we're just going to look at data types. So basically just continuing on from the last video, we declared a variable, x, set it equal to a number. So you might sort of be wondering what's going on here with the fact that we haven't declared any data type for this. So basically what the compiler is doing is it's looking at this number, or whatever we assigned to the variable, and just basically guessing what the data type is. So it's took a guess here and said that this is probably going to be a 4-byte integer. So if we wanted to explicitly say that, we just put a colon here, and we type in I32, and that basically assigns a 32-bit integer, a 4-byte integer here, but we can change this if we want. We can set this all the way down to 8 bits, which obviously just uses 1 byte to store the number. We go all the way up to 128 bits, which is 128 bits to store the number. And we can also change this I to a U to make it unsigned. So that's basically a positive integer. So that cannot go negative. And you know, if we wanted just bigger numbers, if we knew we weren't going negative, then that's when we'll use this. So if I just change this back to I32 here, we can assign in a number of different ways. Obviously, as I've showed you, just decimal numbers. We can do hex. So for example, this. We can do octal by putting 0O and then the octal number like this. We can also assign in binary by doing 0B and then the binary. Sorry, I forgot to mention for decimal actually, we can, for example, if we had a number like 1,000,000, we can actually put underscores in the number and they just get ignored. So basically they can act as like commas to make it a little bit easier to read. And you can do that with binary as well. So something like that. To make it that slightly easier to read, split it into 4-bit sections. And there's also another way, which is the byte, but we'll come back to that in the char section. The other numerical type is floating point numbers. So the default for that is F64. So for example, we put like this, and that's a floating point number. This uses 64 bits because, well, it said in the Rust documentation that 64-bit is just as fast as 32, so that's why it's like that. But if you want to assign a 32-bit floating point number, you can do it like that as well. The other type that I'll cover, another scalar type. Scalar type just means that it's got one type, or one value for the variable. You know, it's not like a list or anything like that. The other one is a Boolean. So that's a keyword. We'll just type in B. This can be true or false. And yeah, that's pretty much self-explanatory. You can use this in if statements and stuff like that. Okay, so the final scalar data type is the char type. So for example, if I come over here, let's see char equals A, like this. That basically just assigns the char type. But this is probably a little bit strange to those of you coming from other languages, because this is actually taking up 4 bytes of space. This is not a 1-byte character, this is a 4-byte character. So I think they've basically just done this so that we can store the entire UTF-8 character set inside a single char data type. So for example, I had an emoji copy there, so we can store an emoji in here. We can store Chinese characters, anything we want in here. But if you want the sort of classic 1-byte character, for example, just type in byte char. It needs to be an unsigned 8-bit integer, and we need to put a B at the front of it. So A like this. So we can log this out here. The byte char is, and for example, we just put this here. Do cargo run now. As well, it interpreted as an integer, so we need to put as char here. And you can see here the byte char is A. So that's basically how we store like a sort of C type of char here, and this is the new Rust char. Alright then, so the final types in Rust are compound types. So that basically means it's not like one value we're assigning multiple different values. So the first one is called the tuple. So basically to declare this, for example, let tup equals, and then we put in brackets like this, or parentheses, whatever you call it. And the advantage of this is these can be different types in here. So this is basically a fixed list. It's assigned in the stack, so it's a fixed size. So we say, for example, 23. We could have like a string, and we could have like a floating point number, whatever. And to access this, for example, tuple value here. And then to access this, we simply just do tup dot, for example, 0. So if we do this, as you can see, 23. If we do tup.1, we should get this SDF printing out, and we do, and that's basically how we access tuples. The other sort of version of this is arrays. So, for example, let r equals, and this is just a sign like JavaScript or something, you know, square brackets, and these all have to be the same data type. This is stack allocated as well, so we can't, you know, it's a fixed size, we can't go adding and removing elements from it. But for example, we go 1, 2, 3, 4, 5, and to access these then, we go R, and then the square brackets here. So for example, R0. And as you can see, we're just able to access all the elements of this. And we cannot, like, obviously we can't have different data types in here, you know. If I put in a string in here, it just won't work, as you can see. Alright, another useful feature of arrays in Rust is we can basically specify the data type in here. So for example, we just put a colon here, put square brackets, and obviously this defaults to I32 because it sees that these are integers. Well, we could change this to U8 or whatever. We can also put a semicolon here, and we can specify the length, so obviously 5 in this case, but you can do that in other languages, just specifying the length of the array here. There's something else cool we can do, so for example, R2, and we can actually type in here, you know, for example, 10. And then we put a semicolon and we put how many we want. So for example, 20. And this will basically fill an array of the number 10 20 times. So in this array, we'll have 20 elements, and they'll all be the number 10. So for example, we just type in R2 and we specify index 15 or something like that. We should get the value 10 printed out. And as you can see, we get the value 10 here. So I forgot to mention about tuples as well. We can basically specify the data types in here of the different elements in it. So we just put a colon here and we put parentheses, and in here we can basically specify the data types like this, which will correspond to the different data types over here. And finally, I had to mention about arrays as well. Yeah, there is actually access checking in Rust, unlike C and stuff like that. So for example, if we just typed in here, array 15, so as you can see, this goes past the edge of the array. We've only got 5 elements in this, and we come up here and type cargo run. As you can see here, index out of bounds, so it basically just doesn't let us do that. And so yeah, that's basically data types in Rust, and I'll see you in the next video.